There's a seismic shift happening at Apple, a fundamental change in how they approach the very core of their technology. It's a move that could redefine the landscape of the entire tech industry. They're now leveraging the power of generative AI, a cutting-edge technology that's rapidly transforming various sectors. And what's their focus? To design the next generation of chips, the very heart and soul of their devices. This isn't just about incremental improvements, it's about a complete reimagining of chip architecture. This isn't a minor tweak, it's not just about making things a little faster or a little more efficient, it's a fundamental overhaul, a complete rethinking of the design process from the ground up. This overhaul impacts how the brains of future iPhones, Macs, and even unannounced devices are created, influencing everything from performance to power consumption. It's a strategic shift with far-reaching implications. Apple Silicon already leads the industry, setting a new standard for performance and efficiency. It's powering everything from MacBook battery life, allowing for all-day productivity and on-the-go creativity, to iPhone's smooth 4K video editing, enabling professional-grade content creation right in the palm of your hand. Now, Apple is letting AI handle, entrusting it with tasks that were once the exclusive domain of human engineers. Specifically, the most complex, time-consuming parts of chip design, the intricate calculations and simulations that demand immense processing power. This is accelerating innovation even further, pushing the boundaries of what's possible in chip technology at an unprecedented rate. Chip design is notoriously difficult, a complex puzzle with countless variables and constraints. It requires the expertise of thousands of engineers, working collaboratively to solve intricate problems. It involves billions of transistors, each one meticulously placed and connected to create a functional circuit. And there's absolutely no room for error. Even the slightest flaw can render an entire chip useless. With AI as a co-pilot working alongside human engineers, Apple's engineers can explore thousands of design options, simulating and evaluating different configurations with incredible speed. They can achieve in the time it used to take to analyze just a few, dramatically accelerating the design cycle. This means faster, more efficient chips, pushing the boundaries of performance while minimizing power consumption. These chips are tailored perfectly to Apple's software and future products, creating a seamless and optimized user experience. The result? A feedback loop where software and hardware are intricately intertwined, each informing and enhancing the other. This synergy allows them to push each other to new heights, driving innovation and creating a competitive advantage. Apple's move signals a new era, a paradigm shift in how technology is developed and deployed. AI isn't just powering apps, it's no longer just about the software layer. It's now building the very foundation of our devices, shaping the hardware that underpins everything we do. The race for the best silicon just got a turbo boost, and the stakes have never been higher. And Apple is leading the charge, setting the pace for the rest of the industry to follow. Let's break it down. What exactly a chip, anyway? At its core, a chip is the brain of your device, the central processing unit, or CPU. It's the component that executes instructions and performs calculations. It's constantly working, running billions of calculations every single second. Think of it as a super-fast calculator, but instead of just adding numbers, it's managing everything from displaying images to running complex applications. It's what makes your phone fast, allowing you to seamlessly switch between apps and browse the web without lag. It's what makes your laptop efficient, balancing performance with battery life so you can work or play for hours on end. And it's what makes your smartwatch smart, tracking your fitness, displaying notifications, and even making calls, all from your wrist. Today, it's not just about speed. Raw processing power isn't the only metric that matters anymore. It's about efficiency and specialization, designing chips that can handle specific tasks with incredible speed and minimal power consumption. A perfect example is Apple's Neural Engine, a dedicated piece of silicon designed specifically for AI tasks like image recognition and natural language processing. Modern chips are increasingly becoming teams of specialists, with different cores and processors handling different types of workloads. They're not just a single brain trying to do everything at once. That's why chip design is such a fierce battleground. Companies are constantly pushing the boundaries of what's possible, because better chips ultimately mean better user experiences, faster performance, and more innovative features. So, what's Apple's edge in this competitive landscape? They design chips specifically for their own software, creating a unique synergy between hardware and software. This allows them to create seamless, responsive devices that feel incredibly intuitive to use. This tight integration is precisely why iPhones feel so fast and fluid, responding instantly to your touch. And it's why MacBooks can deliver such impressive performance while still boasting exceptional battery life. Looking ahead to the future, the rise of augmented reality and the continued advancement of artificial intelligence will demand even more from the chips that power our devices. Devices will need to be able to process massive amounts of data in real time, enabling new and immersive experiences, all while operating efficiently, without overheating or significantly draining the battery. Smarter, more efficient, and more specialized chips are the only way forward to meet these ever-increasing demands. And that's precisely why Apple's investment in AI-assisted chip design is such a potential game-changer, paving the way for future innovations. Apple's chip journey started over a decade ago. It's a story of ambition, innovation, and a relentless pursuit of control over their own technology. This journey represents a fundamental shift in how Apple designs and delivers its products. It began in earnest with the introduction of the A4 chip. This marked Apple's first foray into designing their own silicon, debuting in the original iPad. It was a bold step, signaling a new direction for the company. Shortly after, it also powered the iPhone 4, demonstrating the versatility of this initial in-house design. Before that pivotal moment, Apple, like many others, relied on processors from companies like Intel and other third-party semiconductor manufacturers. But the leadership at Apple recognized that to truly differentiate themselves and control the user experience, they needed control over their destiny, particularly the core technology that powered their devices. The real turning point, the moment that solidified this vision, came in 2020. That's when Apple made the momentous decision to ditch Intel processors in their Mac computers. Instead, they opted to use their own M1 chip in Macs, marking the beginning of the Apple Silicon era for their entire computer lineup. This was a massive gamble, a high-stakes decision with no readily available backup plan if things went wrong. It was a bet on their own engineering prowess and vision, but the M1 proved to be a revelation. It delivered unmatched performance, surpassing expectations and setting a new standard for the industry. It also offered all-day battery life, freeing users from the constant need to find a power outlet. And remarkably, it achieved all of this with silent operation, thanks to its efficient design and thermal management. The success of the M1 unequivocally proved Apple's strategy. Designing their own chips, tailoring the silicon to their specific needs, was undeniably the right move. And with each new chip generation, from the M2 to the M5 and beyond, Apple continues to push the boundaries. They are constantly redefining what's possible in a personal device, enhancing performance, efficiency, and capabilities. It's not just about raw processing speed or benchmark scores. It's about building a solid foundation for the future of computing, creating a platform for innovation that extends far beyond the chip itself. Apple's custom silicon approach lets them innovate freely, unconstrained by the limitations of off-the-shelf components. They have complete control over their hardware and software, ensuring that they are perfectly matched and optimized for seamless performance. This independence is a key reason why Apple can move faster in the technology landscape. It allows them to dream bigger and pursue more ambitious technology goals than the competition. And their relentless pace of innovation shows no sign of slowing down anytime soon. The journey from the A4 chip to the current M-series processors is about more than just incremental improvements in chip design. Ultimately, it's about owning the future of their technology and shaping the direction of the industry. And now, with the integration of artificial intelligence into their chips, that future, a future powered by intelligent devices and seamless user experiences, is arriving even faster than we anticipated. Traditional chip design is a mind-boggling feat. Thousands of engineers, years of work, billions of transistors packed onto a tiny sliver of silicon. The process, called electronic design automation (EDA), starts with a high-level plan and ends with a microscopic city of components. The hardest part? Place and route, deciding where every transistor and wire goes. It's a massive 3D puzzle with endless possibilities, and even with advanced software, it's slow and painstaking. Engineers run simulations, tweak designs, and repeat for months. Each new chip generation adds complexity, pushing traditional tools to their limits. The process is a race against physics, time, and human patience. More complexity means more chances for mistakes and delays. It was clear, something had to change. Enter generative AI, a game changer for chip design. Now, engineers set the goals, and AI explores millions of design options in a fraction of the time. AI learns from each iteration, finding patterns and optimizations humans might miss. It can route wires in unconventional ways, reduce power leakage, and boost performance. Companies like Synopsys and Cadence are leading the way, and Apple is leveraging these tools and building its own. What once took months can now be done in weeks, freeing engineers to focus on big-picture innovation. AI turns chip design from a slow slog into a rapid, intelligent exploration. This is how Apple keeps up with the ever-growing complexity of modern chips. What does AI-powered chip design mean for you? Faster product cycles and better devices. Apple can now bring innovations to market quicker, with each new iPhone or Mac offering real leaps in performance. AI finds the perfect balance between speed and efficiency so your devices last longer and do more. Imagine a MacBook that edits video for hours unplugged, or an iPhone running advanced AI features privately, right on the device. But the real magic? Entirely new products become possible, like smart glasses with real-time video processing and a tiny, cool, efficient chip. Apple's rumored AI servers will also benefit, with custom chips tailored for massive AI workloads. This is AI designing chips that power the next generation of AI, a self-reinforcing cycle of innovation. Apple isn't just making better devices, they're inventing new categories. The future is being built, one AI-designed chip at a time. Meet Johnny Srouji, Apple's Senior VP of Hardware Technologies, and the mastermind behind Apple Silicon. He joined in 2008 to lead the A4 chip, and has since built a world-class engineering team. Srouji's vision? Long-term strategy and flawless execution. The move to Apple Silicon for Macs was his boldest gamble. And it paid off. He's fostered a culture where engineers push boundaries and deliver breakthrough products. Now, Srouji is steering Apple into the AI era, ensuring his team has the best tools to tackle chip complexity. For him, it's not just about software. It's about blending human ingenuity with AI to unlock new innovation. Srouji's leadership is the driving force behind Apple's relentless pursuit of technological sovereignty. The Srouji effect, a future where Apple's chips and products stay ahead of the curve. Apple isn't the only one using AI in chip design. Google, Nvidia, and AMD are all in the race. But Apple's advantage is its tightly integrated ecosystem. They design the chip, the product, and the software. This lets them use AI to optimize for specific needs, not just general-purpose power. While others build engines for everyone, Apple builds a custom engine for its own high-performance race car. Their end-to-end control means AI-driven optimizations have a bigger impact. Apple's in-house chip strategy is now paying off, setting the pace for the industry. As Apple accelerates, competitors must keep up, fueling more investment in AI-driven design. Apple isn't just following the trend, they're raising the bar for everyone. The result? Faster innovation and better tech for all of us. Why should you care? Because AI-designed chips are powering the next wave of experiences. Seamless performance, long battery life, and powerful features, all made possible by custom silicon. Imagine real-time translation, smart glasses with AR overlays, or instant plant identification. These need on-device AI power. AI-driven design means these features become standard, not just for the most expensive devices. The baseline for what your phone or laptop can do keeps rising. The best chip is the one you never notice. It just works, making your life easier. Apple's AI-powered chip revolution is building that future, right inside your pocket.